All right, so this is the last video for section 7.4. We're talking about agresti-cool confidence intervals. So we had the formula for the 95% agresti-cool confidence interval, and now we're going to do an example, somewhat subtle example involving that, right? So we've got a political campaign. The data squad for a politician is preparing to conduct a survey to gauge support. By the way, pause, copy, play. To gauge support for their politician's reelection. When they do this survey, they want to be able to produce a confidence interval with an error of at most 4.4% and a 95% confidence interval. And the question is, how large should the sample size be? How many people should they ask to create this survey, right? Well, that 4% error, that's the margin of error, all right? And what we've seen in the margin of error for the agresti-cool confidence interval is that the margin of error is given by 1.96, the sample proportion times 1 minus sample proportion over n square root. So that's the margin of error for an agresti-cool confidence interval. So we would like that margin of error to be less than or equal to 0.04, right? We are trying to figure out the number of respondents. So we're trying to get a value for n. But we have an inequality with two unknowns. That's no good. So what I'm going to do is I'm going to get rid of one of the unknowns. I'm going to get rid of the p hats by looking at p hat times 1 minus p hat. So what I'd like to say is, how big can that p hat times 1 minus p hat get? Okay. So over here, I create the function p hat 1 minus p hat, but I use x's instead, okay? And I want to maximize it. So I take the derivative, set it equal to 0, and I see at x equals a half, we have a critical value. The second derivative is -2. So at x equals a half, the slope is 0, concavity is negative. So at x equals a half, I have a local max. So x equals a half is a local max. It maximizes x times 1 minus x. So p hat times 1 minus p hat is always less than or equal to 0.5 times 1 minus 0.5, all right? Because p hat equals 0.5 maximizes that product. So instead of setting this inequality less than or equal to 0.04, I'm going to set this, this expression less than or equal to 0.404. I'm going to set this larger expression to be less than or equal to 0.04. And that will guarantee my expression is less than or equal to 0.04. And I've gotten rid of the p hats. So now I'm just going to focus on these two folks. 0.5 times 0.5 is 0.25. Do some algebra, and I crank out, and I get that n has to be greater than or equal to 600.25. So in other words, I have to survey at least 601 people, right? And this is what polling statisticians will do all the time. If you want a good enough result, so like nice and narrow confidence intervals, you have to survey more and more people, all right? Okay, so nice detailed example. One more panel for this video with some homework. All right, so pause, copy, and then play. All right, well, there's also an agresti-cool confidence interval for the difference of proportions. So if we have two separate populations and we want to look at the difference of their sample proportions, agresti-cool provides us an approximation of a confidence interval. So the confidence interval is p1 tilde minus p2 tilde plus or minus the quantile q times this lovely expression. And these p tildes and n tildes should be familiar from an earlier video. The p tilde is the xi plus 1 over ni plus 2. So xi was the number of successes in the ith population, the first versus the second population. So the number of successes in the first population, say, n sub 1 would be the number of people in the first population. And then n sub I tilde is the number of people in the first population plus 2. So we've seen those expressions before. And then Q is going to be the quantile from N01, standard normal, right? The alpha over 2 quantile. So here's some work for you to do. Here's a scenario. We do a survey, 631 males respond, 475 of them indicate they are in favor of the death penalty, 677 females respond to the survey, and 424 of them respond that they are in favor of the death penalty. And we would like to know a confidence interval for the difference of the proportion of men in favor of the death penalty minus the proportion of women in favor of the death penalty. Okay. So we've got the information up here. It's 95% for, so alpha is excuse me. So alpha is 0.05, which means you're looking at the 2.5 and 97.5 quantile for standard normal. So I think you got all the information you need. You should be able to crank out this confidence interval. And when I did so, I got that for my answers. So I hope you do as well. And when I check your work, I'll be looking to see that you actually filled in some details here, please. Okay. All right. And I could be wrong. So if you do it twice and you're never getting anything close to what I did, then you can just throw some paper at me when we get to class. Cool.